let's talk about the definition of a definite integral. So where does it come from? What's the definition? First of all, suppose you have a function. Let f be a function which is defined on a closed interval a to b. We're going to divide this interval into sub-intervals. We divide this interval a to b into sub-intervals. How are we going to do that? We're going to define delta x to be b minus a divided by n, and these are the width of these subintervals. Width equal with delta x. So take a look at this. Here I have an interval. Extend this interval a to b. I'm going to divide this guy up into, for example, two subintervals. This is going to be my starting point. This is going to be my ending point for the first subinterval. And the second subinterval starts at this point and stops at this point. These two have the exact same width. In this case, since I have two subintervals, my n is going to be 2. So delta x is b minus a divided by 2. Whatever a is, whatever b is, we're going to do the subtraction and divide it by 2. If I have 3 subintervals, my n is 3. Delta x is b minus a divided by 3, and I can continue this process. Okay, very good. Now, let my initial point be a. So x sub 0 is a. The next point, x sub 1, then x sub 2, then x sub 3, and I'm going to stop at x sub n, which is equal to b. So again, let's take a look at this. This guy is going to be my x sub 0. This guy is x sub 1, and this guy is x sub 2. X sub 0, x sub 1, x sub 2 with 2 subintervals. If n is equal to 3, I'm going to start at x sub 0, then go to x sub 1, then go to x sub 2, then stop at x sub 3, which is b. Again, if n is equal to 3, my delta x is b minus a over 3 with 3 subintervals, and I'm going to continue this process. Suppose we take some sample points. Let x sub 1 star, x sub 2 star, x sub 3 star, and x sub n star be sample points from these subintervals. So I'm taking some random points, might be the midpoints or so on, from each of these subintervals. X sub I star, which is any of these sample points, belongs to subinterval x sub I minus 1, comma, x sub I. Very good. So this symbol is membership. This guy means member of. Perfect. The definite integral is defined this way. First of all, we denote this guy by S, along S, the minimum A, the maximum B. So this guy is called the lower limit of the integral, and this guy is called the upper limit of the integral. Minimum, maximum of function f of x dx. dx is the same as delta x as n approaches infinity. So dx is the same as delta x as n approaches infinity. So you're taking the limit as n approaches infinity. You're trying to make these very small. This guy is equal to the limit of, here you have the sigma notation. Guys, limit of sigma is this ugly s here. So the limit of sigma I starts from 1 goes to n of f of these sample points times delta x. So again, if you're wondering where this guy came from, this is another name for limit of sigma as n approaches infinity. If this limit exists, we say that, hey, the function is integrable over the interval. If this limit exists, then we say that f is integrable on the interval a, comma, b.